going to talk about damped oscillations. Okay, so a damped oscillation is the one that includes force of friction, and this friction is the one that opposes to the movement. This force is the one that opposes to the movement. So we can define this force as a vector that is equal to a constant times the velocity. It has a minus because it is opposing to the movement. And in the cases when we have a huge velocity, we have to add another constant, which will be a second constant times the velocity to the square. But this term will be used just in case we have a huge velocity. If not, we will have just this formula, which can be written as force of friction will be equal to minus v times the velocity. This v will be the damped constant. So now imagine we have a spring and a mass attached to the spring, and we will have the mass and the constant of the spring and a distance. And by Newton's second law, we know that the sum of the forces will be equal to the mass times the acceleration. And well, the forces that are included in this damped oscillation is, first of all, the force of the spring, which is minus kx. And we also have the force of friction, which will be opposing to the movement, which is, in this case, this way. And the force of friction will be minus v times the velocity. Now, if we have to put these forces into this formula, so we have minus kx minus v times the velocity will be equal to m times the acceleration. And we have to solve this to 0, and we will have kx plus v times the velocity plus m times the acceleration is equal to 0. And now we will divide everything by m. So we have k divided by m times the position of m. This will go, and we will have just that acceleration equals to 0. And now we know that this term is equal to omega, the initial omega, and we know that this term is equal to gamma. So we can rewrite this formula into and this is the formula that describes a damped oscillation movement. If we solve this formula and we put it in terms of the distance in function of the time, we will have that the distance in function of time will be, the formula will be like very similar to the one of a simple harmonic motion. But we know that in simple harmonic motion, the amplitude will stay the same, it will not decrease. But now, as we have the force of friction, the amplitude will be decreasing, so it will look like this. That's why we have to add a new term, which will be an exponential, and it will be to the minus gamma times sine over 2 times cosine of prime omega prime times time plus the constant. have also a new omega because of the same thing that will be the wave will be decreasing. And we have a relationship because this omega is not the same as this omega. So we have another formula that relates these two omegas. And it is omega prime is equal to the square root of omega plus, no, it's minus, sorry, gamma
Square.
and that's it. These are the formulas, the three formulas that explain the movement of a damp oscillation, and it will help you to solve the problems.